The whole world is buzzing about AI right now. It feels like this giant revolution just popped up out of nowhere. But what if I told you this overnight success was actually 260 years in the making? Yeah, let's dig into the real story of how we got here.
So let me ask you a question. How old do you think AI really is? 10 years? 20? Maybe 50 at a push? Well, the core ideas, the actual mathematics that modern machine learning is built on, go back over 2.5 centuries. That's right. The revolution we're all living through has roots stretching back 260 years.
That is the big question for today, isn't it? How can something that feels so brand new, so futuristic, have a past that's that long? Well, to answer that, we're going to take a journey through the key moments, the forgotten breakthroughs, and yes, the cycles of crazy hype and crushing disappointment that have defined the entire history of AI. Okay, so our story starts way back. We're not talking about silicon chips or fancy computers. Nope, we're starting in the 18th century with mathematics. This first era is all about laying the groundwork and, believe it or not, experiencing the very first boom and bust of artificial intelligence. And when you look at this timeline, the sheer scale of it is just wow. We're kicking things off with some fundamental probability theory way back in 1763. Then we leap forward to an incredible vision for what AI could be in 1843. Then we see the first real thinking machine in 1957, only to watch the whole thing come crashing down just 12 years later. It's a real roller coaster. So everything really starts here with a guy named Thomas Bayes. His theorem gave us a mathematical way to handle uncertainty. Think about it. That's a huge problem for AI, right? How do you make a good guess when you don't have all the facts? This is the very bedrock of what we now call machine learning. Okay, now this next part is genuinely mind-blowing. In 1843, long before a real computer even existed, Ada Lovelace was already thinking way beyond just crunching numbers. She imagined that these future machines could handle symbols, that they could compose music or process language. She was essentially describing the core concepts of AI over a century before it was even a field of study. Just incredible. All right, let's fast forward to 1957. We get something called the Perceptron, one of the very first artificial neural networks. And the reaction? It was explosive. The media went absolutely wild with these headlines about electronic brains and thinking machines. This was the start of the very first AI hype cycle. A whole generation was convinced they were right on the verge of solving intelligence itself.
But just as quickly as that hype started, it came to a screeching halt. In 1969, a book came out that just clinically picked apart all the things these early neural nets couldn't do. It was so devastatingly effective that research funding dried up almost overnight. The field was plunged into what we now call the first AI winter. A pretty powerful lesson in not getting ahead of yourself.
So, after that long, cold winter, AI started to thaw out a bit. This next chapter is all about the quiet rediscovery of some of those old ideas and a massive, fundamental shift in how we approach the problem. A shift that would set the stage for everything that was to come. And this right here is a perfect example of a theme you see over and over in AI's history. The math for something called backpropagation, which is a super important way to train neural networks, was actually worked out in 1970. But it basically just sat on a shelf collecting dust until 1986 when researchers rediscovered it. A forgotten idea suddenly became the engine of the next AI revolution. This whole era was defined by a huge pivot in philosophy. For decades, the goal was to build AI by having smart programmers hand code all the rules into a machine. But in the 90s, the whole approach just flipped. Instead of programming the rules, they said, hey, why don't we just feed the machine a ton of data and let it learn the rules for itself? This shift from knowledge-driven to data-driven AI changed absolutely everything. And the power of this new data-driven approach was put on the world stage in 1997. When IBM's Deep Blue beat Garry Kasparov at chess, it was more than just a machine winning a game. It was a massive public demonstration that AI was back, and that this new way of learning from data was incredibly powerful. And that brings us to today, to the modern era. This is where all the pieces we've been talking about finally click into place. You've got the rediscovered algorithms, you've got that data-driven philosophy, and for the very first time, you have enough raw computing power to make it all work on a massive scale.
The acceleration in the last decade or so has been absolutely breathtaking. It's like a chain reaction. It started with the fuel. In 2009, this massive dataset called ImageNet gave algorithms something to actually learn from. Then came the engine, In 2012, AlexNet used that data to crush image recognition. Then we got a new blueprint. The transformer architecture in 2017 completely changed how we handle language. And that led directly to the tools we all see today, like ChatGPT. It's just one breakthrough, directly enabling the next.
So, in 2012, we get one of the most famous experiments of this era. The Google Brain team basically showed a neural network 10 million random YouTube video thumbnails, and it taught itself how to recognize cats. This was a huge deal. It proved these systems could find patterns in messy, real-world data without any humans holding their hand.
I mean, the speed of progress was just staggering. By 2014, Facebook's deep face system could recognize faces with an accuracy that was almost identical to a human's. Think about that. AI was no longer some lab experiment. It was starting to match and even beat human performance at really complex tasks.
Okay, so we've just gone on a 260-year journey, from probability theory to programs that can see. What are the big lessons here? What should we take away from this incredible and kind of crazy history?
I think there are three really important takeaways. First, progress isn't this nice straight line. It happens in bursts, these long quiet periods followed by sudden, wild explosions. Second, a lot of new breakthroughs are actually old ideas that are finally getting their moment because we now have the computing power to make them work. And finally, a little dose of humility is in order. Hubris is a constant in this story. Every generation that has a breakthrough tends to think, this is it. We've finally solved intelligence.
Which leaves us with one final, fascinating question. When you see today's powerful AI not as the end of the story, but as just another point on this very long timeline, it really makes you wonder, doesn't it? If this is where 260 years got us, where could the next 20 years take us, or even the next 2? What old ideas are just sitting on a shelf right now, waiting for the right computer to finally bring them to life?